Hello, Algebra 1 scholars. Welcome to the fourth and final lesson in our Algebra 1 Essentials sequence. This is solving equations, the most important of the four lessons. You need to know how to do this in order to be successful in any other math class. Let's go ahead and get started. Here you have the IXL codes that you're going to complete at the end of the lesson. As before, I'm going to take both of your scores and I'm going to average them out and give you a grade based on the table that you see right here. I want to repeat one more time that this is the most important lesson that you need to know how to do in order to be successful in any other math class moving forward. If you can do this, I have every confidence that you will be successful next year. Here's an overview of what we're going to be doing in this video. Part 1 is going to be focusing on the first IXL code, and it's going to be focusing on when you have variables on only one side of your equation. So we're going to review the basics and do some examples. In part 2, we're going to focus on the type of problems that you'll see on the second IXL code, and that's going to focus on when you see variables on both sides of the equation. And we're going to apply the same things that we learned in the first part and show you different ways that you can solve some of these problems in part 2. Paper and a writing utensil and calculators are all going to be optional for this lesson. What I would recommend that you do is, as you're working on your IXL codes, and if you get stuck, just go back to this video and look for a problem that looks similar to the one that you are trying to do. If you have any questions, message me and let me know. Here are our first three examples. Each of these examples has variables only on one side of the equal sign. And we're being asked to solve each equation for the given variable. When we are solving, remember that our goal is to isolate the variable. We're trying to get our variables on one side of the equation and our constants on the other side. In this case, because of the type of problems we already technically have variables on one side of the equation. We don't really have to worry about that too much, but we have to make sure to get all constants, all regular numbers, to the other side. In order to do this, there's two main steps that we're going to be taking. If possible, we're going to simplify each side, and we're also going to balance the equation using inverse operations. Again, this is meant to be review. I'm not going to talk in detail about how to do each of these problems. I'm just going to talk through the general steps that we take. If you do have questions about the details, please send me a message so I can help you. For this first problem, we have 14 is equal to 11 minus f. For this problem, I cannot simplify either of these sides. 14 is by itself. On the right side, we have 11 minus f. They're not like terms, we can't combine them. So then we have to balance the equation using inverse operations. And again, our goal is to try to get our variable by itself. So here our variable is f. And if we're trying to get f by itself, that means that f should be the only thing that I want to see on that side of the equation. So we need to get rid of that 11. We don't want 11 there. F should be alone. So in order to get rid of 11, we have to use inverse operations. It's a positive 11, so to get rid of that, the inverse would be a negative 11. And when we're balancing equations, we have to remember that whatever we do to one side, we have to do the same thing to the other side. So for this problem, on the left side, 14 minus 11 is going to be 3. And this should be equal to, on the right side, 11 minus 11, this cancels out. So all we have left is negative f. And we're just going to go ahead and drop that down. So here we have negative f. We have our variable on the right side, but we don't want it to be a negative f. We want it to be a positive answer. This technically says negative 1 times f. And same thing, if we're trying to get f by itself, we need to get rid of that negative 1. Since we have negative 1 times f, there is multiplication, the inverse operation would be division. So we're going to divide both sides by negative 1. On the left side, 3 divided by negative 1 is negative 3. And on the right side, we have negative 1 divided by negative 1, which is a positive 1, or just 1f, or f. So f is equal to negative 3. And this is your final answer for that first example. The second example, we have 9h plus negative 18h on the left side and negative 9 on the right side. Similar to before, we're going to ask ourselves, can we simplify this? And in this case, we can. The reason we can is because on the left side, we have two terms that both have the same variable. They are like terms, so I can simplify them. A positive 9h plus a negative 18h, that's going to combine and give us a negative 9h. On the right side of our equation, we have negative 9. And now we're done simplifying. There's no way to simplify each side of the equation. So we move on to balancing using inverse operations. Similar to before, we're trying to get the h by itself. And this right here says negative 9 times h. So in order to get rid of the multiplication, we need to use the inverse, which is division. We're going to divide by negative 9. And whatever we do to one side, we need to do the same thing to the other. On the left side, negative 9 divided by negative 9, this is going to cancel out. So this is going to give us just h is equal to, and on the right side, negative 9 divided by negative 9 is just 1. So h is equal to 1. And last, we have our third example. 15k minus 7k minus 6k plus 3 is equal to 11. Similar to before, I'm going to draw a line down the center of the equal sign. We're going to simplify each side. So let's start off with the left side. We have three terms that all have k values, which means that they are like terms. We can simplify them together. And when we combine a positive 15k, a negative 7k, and a negative 6k, this all combines and equals a positive 2k. We still have a 3 that we're going to go ahead and drop down. We have plus 3 right here. And all of this is equal to 11 on the right side. Now this problem looks very similar to something like number 1. We're trying to get our variable by itself, in this case k. So we don't want that 3 right there. We want to get rid of it. In order to get rid of a positive 3 using inverse operations, again, we're just doing the opposite, so minus 3. In order to get rid of that positive 3, again, we're just using inverse operations, so minus 3 to both sides. Positive 3 and negative 3, this creates a zero-sum pair, so that cancels out. Let's go ahead and bring down the 2k from the previous step. And on the right side, 11 minus 3, this is going to give us a positive 8. So we have 2k is equal to 8. And again, we're trying to get rid of that 2 because we want k by itself. This says 2 times k, so the inverse operation would be division. We're going to divide both sides by 2, and this is going to give us an answer of k is equal to 4. And this is your final answer. These are some of the trickier problems that you're going to see when you're working on your IXL problems. We're being asked to do the same thing. We're solving each equation given the following variable, or the given variable, sorry. Our goal is the same. We're trying to isolate each variable. We're trying to get each variable by itself. But for this one, because we're working with fractions, the thinking process is going to be a little bit different. For example, for step number 1, in the previous problems, we always asked ourselves, can we simplify? And technically, we can do that here too. However, it is not going to be the easiest way. If we do it that way, it's going to complicate our problem a little bit more. So instead, let's focus on inverse operations for this problem. Let me show you what I mean. For the first one, t minus 2 divided by 2 is equal to 3. Our goal is to get rid of that denominator. It's harder to solve equations when we have a fraction like that, so let's get rid of it. We don't want it there. Again, this says divide by 2. And if we want to get rid of that, we need to do the inverse. So here we're going to multiply by 2. And whatever we do to one side, we have to make sure we do the same thing to the other side of our equation. Because this is the inverse operation, 2 divided by 2, that technically just cancels out. So on the left side, we still have t minus 2. And on the right side, we have 3 times 2, so this is going to be equal to 6. Next, we're trying to get t by itself, so we want to get rid of that minus 2. The inverse of minus 2 is plus 2. We do the same thing to both sides. On the left side, we have t is equal to 8 on the right side, and that is our final answer for this problem. In a very similar way, for number 2, we don't want m in the denominator. We don't want to see fractions like this. It makes our problem a little harder to work with. So similar to the way we got rid of that denominator, that 2 at the bottom for the first example, we're going to do the same thing for the second example. Negative 4 divided by m is equal to negative 2. We don't want the denominator. We don't want that m. So we're going to multiply it by m. And whatever we do to one side, we do that to the other side. So on the left side, you have m divided by m. This is going to cancel out, which means that on the left side, we just have a negative 4. And on the right side, we have negative 2 times m, which is negative 2m. We're trying to get our variable by itself. We have negative 2 times m. The inverse operation of multiplication is division, so we're going to divide both sides by 2. Again, we're trying to keep this balanced. We're doing the same thing to both sides. On the left side, we have negative 4 divided by negative 2, which is going to give us a positive 2. And on the right side, we have negative 2m divided by negative 2. This cancels out, so we just have m. m is equal to 2. This is your final answer. The examples that you see here are the last type of examples that you should expect to see when you're working on your IXL assignment, and they all involve distribution. The first one being the easiest type of example with distribution, and then the third example being the slightly harder one. Our thinking process is going to be the same. Technically, there are 2 different ways that we could approach these type of problems. However, I'm going to start off by simplifying and then balancing. This is how I want you to practice these problems. So for the first one, we're going to start off by simplifying. We're going to look at both sides of the equal sign. On the left side, we have 12. We can't simplify that, it's just a 12. But on the right side, we have distribution. We're going to start off by simplifying by actually doing that distribution. So here we have a negative 4 on the outside, which means that we can multiply negative 4 with everything inside of the parentheses. Again, that's distribution. Negative 4 times p is negative 4p. Negative 4 times a positive 9 is going to be a negative 36. On the left side, we didn't do anything, so let's just go ahead and bring down the 12. Next, let's just ask ourselves, can we simplify this even more? Again, the 12 on the left side is just a 12. We can't do anything with that. And on the right side, we can't simplify this. The negative 4 has a p, so it has a variable, and then the negative 36 is just a constant. It's a regular number. They're not like terms. We can't simplify anymore. So let's move on to balancing. We're trying to get our p by itself, which means that we have to get rid of that negative 36. Inverse operations, opposite of negative 36 is a positive 36. And whatever we do to one side, we do the same thing to the other side, so plus 36 here too. On the left side, we have 12 plus 36, which is going to give us a 48. And on the right side, the negative 36 and positive 36 canceled out, so all we have is a negative 4p. Next, we're trying to get p by itself. We know that this says negative 4 times p, so the inverse operation tells us to divide both sides by negative 4. On the left side, we have a negative 12, and on the right side, we have a positive p, since the negative 4 and negative 4 canceled out. So our final answer here is negative 12 is equal to p. The second example is going to be the same thinking process, except that I want to talk about that negative without a number in front of the parentheses. Even though there isn't a number, because we know that it's multiplication, there is an invisible number there. And in this case, it's going to be an invisible negative 1. So similar to the previous example, let's go ahead and distribute that negative 1. So we're going to go ahead and multiply it with z and negative 4. Let's draw our line down the center. Negative 1 times z is negative z. And negative 1 times a negative 4, we're going to treat that as a negative since there is subtraction in front. Negative 1 times negative 4 is going to be a positive 4. And all of this is equal to negative 5 on the left side. Again, we're trying to get our variable by itself, so let's get rid of 4 by subtracting it, the inverse operation. On the left side, we have negative 5 minus 4, which is negative 9. And this is equal to negative z, since this canceled out. Again, there is technically a number in front of z. It's a -1. And since we know that this is multiplication, we're going to use inverse operations and divide both sides by -1, which should give us an answer of positive z on the right side, since this canceled out, and an answer of positive 9 on the left side, since -9 divided by -1 is a positive 9. That means that z is equal to positive 9. That is your final answer. And finally, the last example. It might look a little more complicated, but again, we're going to follow the same thinking process. We're first going to ask ourselves, can we simplify this? Let's draw our line down the center. We're going to start off with distribution. We have a 2 on the outside of the parentheses, so we're going to multiply that with everything inside of the parentheses. 2 times r is 2r. 2 times -2, we're going to treat that as a negative. So 2 times -2 is going to give us a -4. We still have the -2. We didn't do anything with that, so we need to make sure to bring that down. And on the right side of the equation, again, we didn't do anything with the 6, so we bring that down as well. Next, we're going to ask ourselves, can we simplify anything else? And in this case, we can. Since we have a -4 and the -2, they don't have variables, they are like terms. So when we combine them, -4 and -2 is going to give us a -6. We still have the 2r, so let's go ahead and bring that down. And on the right side, we have a +6. We can't simplify anymore since we don't have any like terms. So now let's balance using inverse operations. Since we're trying to get r by itself, let's go ahead and get rid of that -6 by adding 6 to both sides. -6 and +6, that cancels out. So on the left side, we just have 2r. On the right side, 6 plus 6 is a +12. And last step, we know that this is 2 times r, so we're going to divide by 2 to get r by itself. We have r is equal to a +6. That is our final answer. The examples that we're going to do now are going to focus on when we have variables on both sides of our equation, not just on one. Even though the thinking process is going to be the same, we're still using the same steps, our goal is still the same. Because we have variables on both sides, we are going to think about this slightly differently. So for example, the first problem says -9d is equal to -5 minus 4d. If we're trying to get our variable by itself, we run into a problem. We have -9d on the left side, -4d on the right side, and we can't have that. We only want variables on one side of the equation, not on both. So we need to make a choice. We need to get rid of one of these variables. In order to get rid of one of these variables, we're going to balance. We're going to use inverse operations. We're trying to get rid of one of these variables. It doesn't matter what side you put your variable. It could be on the left side or it could be on the right side. But for this problem, one of those two options makes a little more sense. The left side for this problem only has variables, so we have -9d. However, the part on the right has variables and constants. It has both of them. To do this the quickest way possible, since we already have the left side with only variables, I want to keep only variables on the left side, which means that I want to get rid of the variables on the right side. So we have -4d that we want to get rid of. And using inverse operations, to get rid of -4d, we're going to add 4d. But whatever we do to one side, we have to do to the other side to make sure that this remains balanced. So on the left side, we have -9d plus 4d. This is going to give us a -5d. On the right side, this canceled out because this is inverse operations. So all we have left over is that -5 that we just bring down. Again, we're trying to get d by itself. We know that this says -5 times d. So to get rid of that -5, we're going to use division. Divide by -5. And whatever we do to one side, we do the same thing to the other side. -5 and -5, that cancels out. We have d is equal to -5 divided by -5. That's a +1. So d is equal to +1 for this first example. The second example says -4 plus 9p is equal to 10p. Same as before, we want variables on one side and constants on the other. Since we have 10p, we have variables only on the right side, it would make sense to keep variables on the right side for this problem, which means that we need to get rid of 9p. We don't want 9p there. We only want variables on one side. So to get rid of a positive 9p, we are going to subtract 9p. Whatever we do to one side, we do to the other. Positive 9p and negative 9p, this cancels out. So let's go ahead and bring down a negative 4. On the right side, 10p minus 9p, this is equal to 1p. You might be tempted to do some division right here, but we technically don't need to. 1p is the same thing as just saying p. P is already by itself since there's only one. It's already by itself. And on the left side, we have a negative 4. So this is our final answer. Negative 4 is equal to p. Here are some level 2 type problems. They're only a little more complicated than the ones that we just did. Again, the thinking process is going to be similar. We want variables only on one side. But first, let's ask ourselves, can we simplify anything? On the left side, we have 7 minus 2n. So no, they're not like terms. And on the right side, we have negative 5 minus 4n. No, again, they're not like terms. So now that we know that we can't simplify, let's start balancing. We have variables on two sides of the equation. We have negative 2n here, and we have negative 4n here. Again, we don't want variables on both sides. We only want variables on one side. So here we need to make a choice. We need to get rid of either the negative 2n, that way that there's only variables on the right side, or we could get rid of a negative 4n to get rid of the variables on the right side. What I like to do in these type of problems is get rid of the smallest one. It's going to help make our calculations a little easier. The smaller one of these two is going to be negative 4n. Again, it's more negative because negative 4 is smaller than negative 2. So to get rid of negative 4n, we're going to have to add 4n. And whatever we do to one side, we're doing the same thing to the other side. On the left side, the 7 doesn't change. It's still just a 7, but we have negative 2n plus 4n, which is going to become a positive 2n. And on the right side, this cancels out, so all we have is a negative 5 that we bring down. Next, again, we're trying to get our variable by itself, so we have to get rid of the 7 and the 2 on the left side. Let's start off by getting rid of the 7. It's a positive 7, so to get rid of that, we're going to subtract 7. And whatever we do to one side, we need to do the same thing to the other side. 7 minus 7, that's a 0. So we bring down the 2n, and this is equal to negative 5 minus 7 is a negative 12. And our final step, we know that this is 2 times n, so the inverse of multiplication is going to be division. We're going to divide both sides by 2. That leaves us with n is equal to negative 6. Now let's do the second example. Similar to before, let's see if we could simplify each of these sides. On the left side, we have 10 minus 5z plus 4. We do have like terms. We have a 10 and a positive 4. They're just regular numbers that we can combine. When we do combine these, a 10 and a 4 is going to give us a positive 14. We still have the negative 5z that we're going to go ahead and drop down. Again, we didn't do anything with it. It's still part of our problem. And on the right side, there's nothing that we can simplify, so we have negative 9z minus 10, since they are not like terms. Next, we have to make a choice. We have variables on both sides, and we don't want that. We are going to get rid of the smaller of the two variables, negative 5z and negative 9z. The smaller one is negative 9z because it's more negative. To get rid of that, because it is a negative 9z, we are going to add 9z. Whatever we do to one side, we do the same thing to the other side. That's going to give us 14 plus 4z, since negative 5 plus 9 is a positive 4. And on the right side, negative 9z plus 9z is going to cancel out, so all we have is a negative 10. We're trying to get z by itself, so let's get rid of that 14 by subtracting. We do the same thing to both sides. Positive 14 and minus 14, that cancels out. So we have for z on the right side, negative 10 minus 14 is going to give us a negative 24. We're trying to get z by itself. This is multiplication, 4 times z. So we use the inverse, divide by 4 to both sides. We have z is equal to negative 6. This is our final answer. And finally, we have the hardest type of problems that you will see on these IXL problems. If you want a chance to try this on your own, go ahead and pause the video. Otherwise, let's just go ahead and get started. Same as before, we're trying to simplify first. For the first example, we have 20r on the left side. We can't simplify that. It's just 20r by itself. On the right side, however, we can simplify. According to the order of operations, we are first going to multiply. So in this case, it's distribution. It's just a special kind of multiplication. We're going to take that sign in front of the 3, so negative 3, and we're going to distribute that to everything inside of the parentheses. This is going to give us a positive 24r minus 60. We still have a negative 12 here on the right side, and on the left, we're going to drop down the 20r since there's nothing that we did with it. Next, is there anything else that we can simplify? On the right side, yes, we have a negative 12 and a negative 60. They're just regular numbers, they're like terms. And when we combine those two numbers together, we get a negative 72. We still have a 24r that we're going to go ahead and drop down, so 24r, and on the left side we still have 20r. There's nothing else that we can simplify, so now let's go ahead and start balancing. Since I have 20r, we'll have a variable on the left side already by itself. I want to get rid of the variable on the right side. It's just going to save some time. To get rid of that positive 24r, let's go ahead and subtract 24r. Whatever we do to one side, we do the same thing to the other side. On the left side, we have a negative 4r. On the right side, we just have a negative 72, since this canceled out. And our final step here is going to be to divide both sides by negative 4, which gives us an answer of r is equal to a positive 18. The only difference between this last example and what we've been doing before is that now we're dealing with decimals, but everything else is still the same thinking process. Same as before, we're going to ask ourselves, can we simplify either of these sides? If we look at the left side, our first number does not have a variable and our second one does, which means that we can't combine them. They are not like terms. On the right side though, we have two terms right here that both have r. They are like terms, which means that we can't combine them. When we combine both of these, we get a negative 15.2r. And then we bring down the positive 6.28. Again, we didn't do anything with it. It's still part of our problem. And on the left side, same thing. Because we couldn't simplify anything, we still have negative 12.72 and a negative 16.2r. Next, we're just trying to balance the equation. We want r's, our variables, only on one side. I'm going to get rid of the smaller one. And in this case, the smaller one is the negative 16.2r, so we're going to add 16.2r to get rid of it. And whatever we do to one side, we need to do the same thing to the other. On the left side, we just have negative 12.72, and on the right side, this is going to give us a positive 1r plus 6.28. Because we're trying to get r by itself, we need to get rid of the positive 6.28. So let's go ahead and subtract 6.28 to both sides. This is going to give us a negative 19 on the left side and a positive 1r on the right side. And because we know that 1r is just r by itself, this is your final answer. Negative 19 is equal to 1r, or just r. And that is it. Go ahead and get started on your final IXL codes. Again, I will be averaging both of your scores to give you your final grade based on the table right here. If you have any questions, please feel free to message me. And that's it. Have a good rest of your day. Take care, everyone. Bye.